juniors?
Both.
Seniors.
Both.
Seniors graduating next year and the year after.
All right.
Some of them next year, some of them the year after.
Oh yeah, you make all
Okay. You guys saw Cimarron 5 when we drove through. You saw how it was just like Cimarron 4. We had the VFD and the generators for our downhole pumps. Here's Cimarron 2. This one's in the Currachine formation. Lower, it's in the Triassic region of the geological zone. Higher pressure, lighter crude. The crude here is around 39 degrees API. Those previous two wells are from 15 to 18 degrees API. Very thick, viscous fluid. So you can see the same setup with the Christmas tree in our master valves. And here we only have one wing valve. And it comes down again to the flow line. And we have the first sets of little cylinders on top there. Those are those pilots I was talking about. Those are what help us keep it safe and shut in the well as needed. You can see all the little tubing coming off of that, and we'll walk over to the panel here in a minute and I'll show you how that works with the air pressure and how it keeps these valves open. But we have chemical injection, same here as we are on the other well, but both of these chemicals are injected here at the wellhead. We don't have corrosion inhibitor downhole. You can see this little section, see how the pipe comes up? That's for sampling. So
storage.
as we're pumping this fluid, if you have laminar flow, you're going to have oil on top and water on bottom. And so it's hard to get a representative sample of your well stream. So that's why you'll put a dip like that so that when it gets in the vertical, it'll mix and you can get a proper sample. You'll see that on a lot of wellheads. We have our metal piping that connects to this white plastic line. That's the Soluforce line. It's an insulated plastic line that handles corrosion a lot better than metal. Easier to install also. Price-wise, it can be, depending on the diameter, it can be about the same as metal pipe. It's just easier to install and better for corrosion. Back there, those trucks, those are our produced water hauling trucks. When we get to the plant, we'll show you where we're loading those trucks. We just park them up here for now. Nothing real big about those. Let's follow the flow line over here to this panel.
Mana banyak sias kerjanya syarikat apa dia? Sayang mas. Flow line.
You can see all these lines coming off. These all go, and we've buried them, and these are all air hydraulic lines. So these are what you have your master valve, your wing valve, and your flow line valve. Along with, on this well, we have a subsurface safety valve. So about 150 meters down inside the tubing, there's a valve that is held open by pressure. Again, that's another safety valve in case you lose integrity of your wellhead. You'll lose the air pressure and that valve will shut, and it'll shut in all the flow from the reservoir. But you see, just real quick, so here's SCSSV. That's our subsurface safety valve. Right now there's 3,000 pounds. So there's 3,000 pounds coming off of one of these lines, and it goes downhole and it's holding open that valve. Same for our master valve. You see your master valve. We're holding it open with around 60 PSI. Wing valve's the same, it's 55, 60 PSI. So this is called your well control, or your well panel. So that's what controls all the valves and pilots on that flow line.
Is it always that stable?
Yes, these are. It's a closed system. This has nothing to do with the reservoir pressures. It's only for the safety system. We have a air compressor in that little building right there that will keep these pressured up and open. You also have your H2S shut-ins. So you can see this panel. You can see H2S 1, 2, 3, 4, and 5. Right there is one of the H2S sensors. And if you look back, you can see them around the wellhead in different spots. So what that does is they sense H2S at a certain ppm. I believe it's over 20 ppm right now. It'll shut in the well. So that panel will talk to this panel, will release your pressure and shut a valve. It senses a leak somewhere. And it's all for surface protection. I think that's about it here. Any questions?
What are those canisters?
Those are our breathing air. That's for safety. So anytime we come and we gather a sample, or say we have an H2S alarm, that's where we don the SCBA mask, and that's our supplied air to the mask, so that we can work on the panel if there's an H2S release. And you can see back there by the wellhead, there's another bundle of canisters. So anytime we're having to work on the wellhead, we'll mask up for safety. Any other questions?
What are those gauges that's shut?
These are these gauges that you have it. These are built so you can add different safety mechanisms. We used all that we needed, and that's just so that no one comes up here and reads those gauges. There's nothing in them. They're not plumbed into anything. You can see some of these are blank.
Yeah, two of them.
So we have room to install more safety features if needed. But just for us, and so we don't get confused, we tape it up. I think that's about it. Any other questions?
How much is the leak of the well?
This one is producing out of the Currachine. I believe it's around 3,200 meters. Total depth of this well, I think, was 3,600 meters, around there. Higher pressured.
Vertical well?
Yes, all our wells here are vertical. We have not drilled any horizontal or directional S-shaped wells here in Kurdistan yet.
How much the pressure?
Bottom hole pressure here is around 3,000 psi. Over on Simrit 5, the one we drove through, and Simrit 4, they're around 2,200 to 2,500 psi. Anything else?
The production rate?
Production rate, good question. This one right now, we're producing around 22 to 2,500 barrels a day.
So the valve is not fully open, right?
This one is not. We're trying to hold back production so that we do not bring in water and cone the formation with water. We did have it up to 3,000 barrels a day, and our water production went up. My opinion here, these are highly fractured carbonate reservoirs. So you don't have as much of a coning issue as you would see in a sandstone formation. But with all the fractures here, as you produce more, it's going to bring the water from further away through all those fractures. So that's why closing the choke a little more, you're able to shut the water off. Normal sandstone reservoirs, once you bring the water in, it's hard to stop it. Very unique reservoirs here. Geologically, they're very tough to drill with all the fractures and subsurface tectonics around here. It's a very unique area for land production wells.
Is it good? Or
Not good.
okay.
Not good. I mean, it's good for the fractures are good for the production, But while drilling the well, it makes it a lot harder. You lose circulation, or you have zones communicating through fractures. You know, high pressure zones communicating at a higher depth, so you're not ready for it. You take a kick while drilling. Very tough wells to drill. They are.
What about
So-
porosity on
Porosity here, I forget the actual readings. It's not too high. Carbonate, the permeability is very high with all the fractures. In the rock itself, I'm not real sure exactly what the permeability is. But in the reservoir, since it's highly fractured, you have a higher permeability.
So if you have continued on the 3,000 production rate, the water would have taken over the reservoir, and
We don't know. You know, we're still learning a lot about this reservoir. We've just recently got out of exploration. We just started producing this well 6 months ago. So we're learning every day. Every day as the pressures change, temperatures change, as the water comes, we're learning something new. We knew water would come at some point. We didn't know when. Right now, it took 6 months. How much water we're gonna get, we don't know that either. We take samples every day. We measure the BS&W, the base sediment in water. Basically, it just tells you how much water's in your oil. And that's changing on a daily basis. With the startup of a new plant, we have a lot of upsets, so we can't continuously produce this well. So it makes it harder for us to learn about these wells. So next year, maybe we'll know more, but it's continuous.
so after you increase it to 3,000 the production, to which level the production of the water reached until you thought that this is a risk, and then you reduce the
We
production
reached,
again?
so 3,000 barrels, we got up around 10% water.
So that's too much.
That's too much. That's 300 barrels a day.
Okay.
As you know, once you get the water, you have to dispose of it. So we have to truck the water out here to another well site and pump it down hole. So
Which level of water is normal?
what's that?
The percentage of water which is normal.
Normal here, I've seen companies have upwards of 20% water, 20%. I know like Gulf Keystone, they report 0 water. For
So
us,
it differs.
yeah, there's a big difference. And again, it's this area geologically, it's very
Right.
differs from well site to well site, formation to formation.
Is it same reservoir?
They are. So Gulf
Yeah.
Keystone is
Yes.
in the higher one, the Musa Daya,
Yeah.
in the Jurassic. Yeah, Triassic. This is Triassic, the lower. Jurassic's the higher. They are in the same formation.
They are actually behind this mountain, you see?
Yep.
We see their flare, like from the other side when we come, we can see their flare. So their formation is close to us.
The properties of the oil are very similar, but the depths and the pressures and the water, it's all different from ours. So, but we talk to them all the time. We talk to all the other producers, just trying to learn, trying to figure out this area.
All right.
All right, we'll go to the plant next and continue this.
What about the water that were over there?
Oh,
Water pools?
pool?
Yeah, the water pools.
Those are one
Storage.
supplies water for our toilets and our sinks at the PF. The other one is a cooling pond for as we pump water through our process in the plant, it heats up. Our water tanks can't handle the heat. They're rated to a certain temperature, which is about 140 degrees Fahrenheit. And so we have to ship it to that upper pond and let it cool. And then we pull from the bottom of that pond and pump the water back in.
Cool.
So what's the pressure of the crude oil when it transfers from this?
This one comes out of the wellhead, I want to say 120 degrees Fahrenheit.
So isn't it too hot to be transferred using this plastic?
No, they're specially designed for it. They're insulated. I forget the name of the plastic itself, But you can Google Soluforce, and it'll Soluforce line, and it'll give you all the specifications of that. Yep.
Thank you.